The morning of November 19th, 1944. Somewhere in the Ardennes forest, eastern France, a German reconnaissance patrol moved carefully through the fog-shrouded underbrush, searching for abandoned American equipment. What they found instead would trigger a crisis that reached all the way to Berlin. A United States Army Jeep sat beside a muddy track, abandoned but undamaged. Its olive drab paint was splattered with mud. The hood bore no bullet holes. The engine was intact. This was not uncommon. German soldiers had captured hundreds of these vehicles throughout the campaign in France. Wehrmacht mechanics had learned to appreciate their four-wheel drive, their reliability, their ability to traverse terrain where German vehicles struggled. Officers coveted them. Tank crews requisitioned them when they could. The Jeep had become the most desired American vehicle in the German military inventory. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But this particular Jeep would take an unusual journey. Instead of being pressed into immediate service, it was flagged by a Wehrmacht technical intelligence officer attached to the division. Orders came down from Army Group headquarters. This vehicle was to be transported, intact, to the technical evaluation facility at Kummersdorf, south of Berlin. The engineers there had standing orders to examine examples of enemy equipment, particularly anything the Americans produced in quantity. The Jeep arrived at Kummersdorf in early December 1944. The facility had seen better days. Allied bombing had damaged portions of the complex. Skilled technicians were increasingly rare, many having been drafted into combat units as Germany's manpower crisis deepened. But the examination of this vehicle received priority attention. The reason was simple and disturbing. German military intelligence had been compiling reports about American production capacity, and the numbers seemed impossible. Hauptmann Werner Ossenberg supervised the technical evaluation. He was 42 years old, a mechanical engineer who had worked for Opel before the war. He had examined Soviet tanks captured on the Eastern Front, British vehicles from North Africa, American trucks from Italy. His job was to assess enemy equipment for vulnerabilities, but also to understand manufacturing techniques, material choices, design philosophy. In this work, he had developed a grudging respect for Allied engineering, particularly American mass production methods. The Jeep that arrived at Kummersdorf was a 1943 Willys MB. Serial number indicated it had been built at the Willys Overland plant in Toledo, Ohio. It was one of hundreds of thousands that had rolled off American assembly lines since 1941. To Ossenberg, it appeared unremarkable. Just another vehicle. He ordered his team to begin a detailed examination. They started with the exterior, measuring dimensions, noting construction techniques. The Jeep was compact, barely 3 meters in length, just over 1.5 meters wide. It weighed approximately 1,000 kilograms, less than Germany's Kübelwagen counterpart. Yet it featured four-wheel drive, which the Kübelwagen lacked. The hood was flat, useful as a makeshift table. The windshield folded down. The body panels were stamped steel, simple in design, easily replaced. Then they examined the chassis. Ossenberg noted the frame construction, heavy steel rails that provided structural rigidity. The suspension used leaf springs, a simple, robust design that required minimal maintenance. The drivetrain featured a transfer case allowing power to be sent to all four wheels. The differential was straightforward, using components that appeared to be standardized across multiple vehicles. The engine drew particular attention. It was a Willys L-head inline, 4-cylinder, producing 60 horsepower at 4,000 revolutions per minute. Not particularly powerful by German standards, but adequate for the vehicle's weight. What impressed Ossenberg was the engine's simplicity, fewer moving parts than comparable German designs, easier to service. The oil filter was accessible, the spark plugs could be changed quickly. Everything about the design suggested it had been engineered for maintainability under field conditions by mechanics with minimal training. The transmission was equally simple, 3 forward gears and reverse. No synchronized gearbox, but that reduced complexity and cost. Shifting required double clutching, a technique any driver could learn. The reduction gears in the transfer case provided low-range capability for difficult terrain. Everything was mechanical, robust, designed to work even when damaged. Ossenberg spent days examining every component. He noted the quality of the steel used in the frame. He observed the welding techniques, which, while not as refined as German methods, were more than adequate for the vehicle's purpose. He studied the electrical system, noting its simplicity and the accessibility of the wiring. He examined the fuel tank, the brake system, the steering linkage. Everything he saw reinforced a single conclusion. This vehicle had been designed specifically for mass production. Then came the moment that changed everything. Ossenberg ordered his team to disassemble the transmission. This was standard procedure for technical evaluation. Understanding the internal components allowed assessment of manufacturing quality, metallurgy, and design sophistication. The mechanics removed the transmission from the vehicle, placed it on a workbench, and began the careful process of opening the casing. What they found inside stopped them cold. The gears were precisely machined, yes, but what shocked them was not the quality of the individual components. It was the implications of how they had been made. The gear teeth showed evidence of having been cut using automated machinery, almost certainly multi-spindle gear cutters operating at high speed. The bearing surfaces had been ground to tolerances that suggested dedicated grinding machines rather than general-purpose equipment. The synchronizer rings, while absent in this non-synchronized transmission, were clearly designed to be added or removed with minimal retooling. Every single component inside that transmission told the same story. This was not a transmission that had been carefully assembled by skilled craftsmen. This was a transmission that had been designed from the ground up to pour off an assembly line, component after component, hour after hour, with minimal human intervention. Ossenberg sat in his office late that evening, studying his notes. The implications were staggering. If the Americans could produce transmissions of this quality at mass production speeds, then the reports about American output were not exaggerations. They were conservative estimates. German intelligence had been tracking American vehicle production since early in the war. The numbers had seemed fantastical. Initial reports suggested the Americans were producing tens of thousands of these Jeeps every month. Wehrmacht officers had dismissed these figures as Allied propaganda. No nation could possibly manufacture vehicles at such rates. The logistical requirements alone would be overwhelming. The tooling costs would be prohibitive. The workforce required would number in the hundreds of thousands. But this transmission told a different story. Every component had been designed for automated manufacture. The casing was a simple casting that could be produced quickly using sand molds. The gears were cut using machines that could operate continuously with minimal supervision. The assembly process required no special skills, just workers following simple procedures. The entire transmission could be assembled in minutes by workers who had been trained in days, not years. Ossenberg requested the intelligence files on American industrial capacity. What he read kept him awake through the night. The Willys Overland plant in Toledo was producing approximately 1,500 Jeeps per day. The Ford plant at Highland Park was producing similar numbers. Between them, these two facilities were manufacturing approximately 3,000 Jeeps every single day, 7 days a week. The numbers seemed impossible until Ossenberg did the mathematics. 3,000 Jeeps per day translated to 90,000 per month, over 1 million per year, and these were just two facilities producing one type of vehicle. American factories were simultaneously building trucks, tanks, aircraft, ships, and countless other pieces of military equipment. The transmission sitting on his workbench represented something far more threatening than any German weapon could address. It represented an industrial capacity so vast that Germany could not hope to match it. Every Jeep transmission rolling off an American assembly line was evidence of a manufacturing juggernaut that dwarfed Germany's entire industrial base. But the true horror the realization that would shake Osenberg's confidence in Germany's ability to win the war was still to come, because the implications of what that transmission represented went far beyond simple vehicle production. It revealed the fundamental disparity between German and American approaches to warfare, and that disparity was measured not in tactical superiority or strategic genius, but in the cold arithmetic of industrial output. German military planning had always emphasized quality over quantity. German engineers designed superior weapons. German craftsmen built them to exacting standards. German soldiers wielded them with skill and courage. This philosophy had served Germany well in the war's early years, when superior tactics and equipment allowed smaller German forces to defeat larger Allied armies. But as the war dragged on, as Germany's conquests expanded and its supply lines stretched, as Allied bombing disrupted production and skilled workers were drafted into combat units, the limitations of this approach became apparent. Building the best tank in the world meant nothing if you could only build 50 of them, while your enemy built 5,000 tanks that were good enough. The Jeep transmission embodied a different philosophy. It was not the best transmission possible. German engineers could certainly design something more sophisticated, more refined, more efficient, but that was precisely the point. The Americans had not tried to design the best transmission. They had designed a transmission that was good enough, that could be manufactured quickly, that could be repaired easily, that could keep working even under conditions that would destroy more sophisticated designs. This represented a fundamental difference in military-industrial philosophy that German planners had failed to comprehend. While Germany struggled to produce a few hundred King Tiger tanks, each one a masterpiece of engineering, the Americans were producing thousands of Sherman tanks that were simpler, more reliable, and easier to maintain. While German aircraft factories carefully assembled Messerschmitt fighters using skilled labor and precision techniques, American factories were churning out thousands of P-51 Mustangs using assembly line methods borrowed from automobile production. Osenberg drafted his report over the following days. He detailed the Jeep's specifications, its design philosophy, its manufacturing techniques. But the core of his report was not about the vehicle itself. It was about what the vehicle represented. In carefully worded technical language, he explained that American industrial capacity exceeded Germany's by a factor that made victory impossible through attrition. The report reached Berlin in mid-December 1944. It circulated through various offices at Wehrmacht High Command. Some officers dismissed it, others studied it carefully but saw no solutions. The brutal truth was that by late 1944, everyone who was paying attention already understood that Germany had lost the war. The question was not whether Germany would lose, but when, and at what cost. But for men like Osenberg, who had devoted their professional lives to German technical superiority, who had believed in the myth of German engineering excellence as a decisive military advantage, the Jeep transmission was a devastating revelation. It demonstrated that superior engineering meant nothing against an opponent who could simply outproduce you 10-1, 20-1, 50-1. The story of how America achieved this production miracle began years before Osenberg examined that Jeep transmission in his workshop outside Berlin. It began with a challenge that seemed impossible, a timeline that seemed absurd, and a temp philosophy that would revolutionize warfare. July 11th, 1940. The United States Army issued a requirement to 135 American automotive manufacturers. The Army needed a light reconnaissance vehicle to replace its aging motorcycles and Ford Model T cars. The specifications were demanding: four-wheel drive, crew of 3, wheelbase of no more than 80 inches, fold-down windshield, 660-pound payload, and an engine capable of 85 foot-pounds of torque. The timeline was even more demanding. Companies had 11 days to submit proposals. They had 49 days to deliver a working prototype. They had 75 days to produce 70 test vehicles, 130 days total to design and deliver functional military vehicles from scratch. Of the 135 companies contacted, only 2 submitted bids: American Bantam Company and Willys Overland Motors. The challenge seemed impossible. No automotive manufacturer in history had developed a completely new vehicle in such a compressed time frame. But these were not normal times. War was sweeping across Europe. France had fallen to German forces in June. Britain stood alone against the Nazi war machine. President Franklin Roosevelt understood what many Americans did not yet grasp. Their nation would be drawn into this conflict, and when that happened, they would need to mobilize on a scale never before attempted. American Bantam delivered the first prototype in September 1940. It weighed 1,250 pounds, exceeded the weight limit, but demonstrated the basic concept worked. The Army tested it extensively at Camp Holabird in Maryland. The vehicle performed admirably, but American Bantam was a small company that lacked the production capacity the Army would eventually require. The Army invited Willys Overland and Ford Motor Company to study the Bantam prototype and develop their own versions. This decision, controversial at the time, proved crucial. By early 1941, all three companies had produced test vehicles. The Army evaluated them side by side and made a practical decision: standardize the design using the best features from each company. The Bantam's Spicer four-wheel transmission and differential were mated with the Willys Go Devil engine and fitted with Ford's overall bodywork configuration. The result was the Willys MB and Ford GPW, the vehicles that would become known simply as the Jeep. Production began in earnest in late 1941. Charles Sorensen, Ford's production chief and the architect of the Model T assembly line back in 1913, understood immediately what this vehicle represented. It was not just a military vehicle. It was a platform for demonstrating American mass production capability. Every Jeep that rolled off the line was a statement. America could manufacture quality products at speeds that would overwhelm any adversary. By 1943, the production numbers were staggering. Willys Overland produced over 360,000 Jeeps during the war. Ford produced over 270,000. Total production exceeded 640,000 vehicles. At peak production, American factories were building over 3,000 Jeeps per day. 3,000. Every single day. These numbers represented approximately 18% of all wheeled vehicles built by America during the war. But the Jeep was just one product among thousands. American factories were simultaneously producing trucks, tanks, artillery pieces, aircraft, ships, ammunition, uniforms, medical supplies, and countless other items. The scale of American industrial mobilization exceeded anything the world had ever seen. To understand the magnitude of this achievement, consider what was happening simultaneously at other American facilities. At the Chrysler Tank Arsenal in Detroit, workers were producing M3 medium tanks at rates that shocked military observers. The facility produced its first tank in April 1941. By 1942, production had ramped to over 1,000 tanks per month. The plant eventually produced over 22,000 tanks during the war. At the Kaiser shipyards in Richmond, California, workers were building Liberty ships using revolutionary modular construction techniques. A Liberty ship was a cargo vessel over 440 feet long, capable of carrying 10,000 tons of supplies. Traditional shipbuilding took months to construct such a vessel. Kaiser's workers reduced the time to under a month. At peak efficiency, they built one Liberty ship in just 4 days, 15 hours, and 29 minutes. The United States built over 2,700 Liberty ships during the war, more tonnage than the entire Japanese merchant fleet. But perhaps the most dramatic demonstration of American industrial capacity was occurring at a facility outside Ypsilanti, Michigan. The Willow Run bomber plant, designed by industrial architect Albert Kahn and supervised by Charles Sorensen, was attempting something that aviation experts claimed was impossible: mass production of heavy bomber aircraft using automobile assembly line techniques. The B-24 Liberator was a 4-engine heavy bomber designed by Consolidated Aircraft. It was 67 feet long, had 450,000 parts, and 360,000 rivets in 550 sizes, and weighed 18 tons. Aircraft industry executives scoffed when Ford announced plans to produce these complex machines using automotive manufacturing methods. Dutch Kindelberger, president of North American Aviation, sneered, "You cannot expect a blacksmith to make a watch overnight." Charles Sorensen proved them wrong. In January 1941, he visited Consolidated Aircraft's plant in San Diego to observe B-24 production. What he saw appalled him. Workers were assembling aircraft outdoors on steel fixtures. They used surveyors' transits mounted on pickup trucks to align engine mounts. The entire process was inefficient, slow, dependent on highly skilled craftsmen performing custom work on each aircraft. Sorensen locked himself in his hotel room that night with pencil and paper. By 4 in the morning, he had sketched out a plan that would revolutionize aircraft manufacturing. He envisioned a plant 1 mile long and 1/4 mile wide, the largest single industrial building ever constructed. The aircraft would be broken down into 11 major assemblies, then further divided into 69 sub-assemblies. Each would be manufactured separately, then delivered in sequence to the main assembly line. Construction of Willow Run began in April 1941. The plant was L-shaped, covering over 3.5 million square feet. The assembly line was over 1 mile long, featuring 4 large turntables that allowed the production line to make a 90-degree turn before continuing to final assembly. It was, as Albert Kahn boasted, the most enormous room in the history of man. The first B-24 rolled off the Willow Run line in September 1942, but production was slow initially. Ford struggled to adapt automotive manufacturing techniques to aircraft assembly. The government constantly changed the B-24's design, requiring expensive retooling. Critics called the facility "Will It Run?" Congressional committees investigated. Then Ford's engineers solved the critical problem: wing assembly. Consolidated Aircraft built each center wing using temporary jigs, requiring 250 man-hours per wing. Ford engineers created permanent jigs into which wings could be moved by overhead crane. They reduced the time to 1 hour, 1 hour per wing. The implications were staggering. By November 1943, Willow Run produced its 1,000th B-24. By April 1944, the plant was producing 453 aircraft in 468 working hours. That equated to 1 finished B-24 Liberator every 63 minutes. Every 63 minutes, a 4-engine heavy bomber, ready for combat, rolled out the doors at Willow Run. The plant operated 2 9-hour shifts, 6 days a week. At peak production in mid-1944, Willow Run accounted for half of all B-24s produced that year. The facility eventually built 8,645 Liberators, producing more of these aircraft than the combined output of 4 other factories. The cost savings were equally impressive. When Consolidated Aircraft built B-24s using traditional methods, each aircraft cost $379,000. Using mass production techniques at Willow Run, Ford reduced the cost to $216,000 per aircraft. Lower cost, higher quality, vastly greater production volume. This was American industrial power at its peak. In 1944 alone, Willow Run produced nearly as many aircraft as the entire nation of Japan. Let that sink in. One American factory, producing one type of aircraft, outproduced an entire industrialized nation's aircraft industry. German military intelligence tracked these numbers with growing alarm. Reports from various sources painted the same picture. American production capacity exceeded German estimates by orders of magnitude, but many German officials dismissed these reports as propaganda. The numbers seemed too large to be credible. On May 26, 1940, President Roosevelt had delivered a fireside chat to the American people. In that address, he called for the production of 50,000 combat aircraft over the next 12 months. Adolf Hitler was told by his advisers that this was American propaganda. In 1939, annual aircraft production for the United States military was less than 3,000 planes. Producing 50,000 in a year was simply impossible. By the end of the war, American factories had produced over 300,000 aircraft. 300,000. Roosevelt's supposedly impossible target of 50,000 per year had been exceeded by a factor of 5. American aircraft production peaked in 1944 at 96,000 planes, nearly double Roosevelt's audacious goal. Tank production told the same story. Germany produced approximately 25,000 Panzer IV medium tanks during the entire war. American factories produced 49,000 M4 Sherman medium tanks. America built nearly twice as many of a single tank model as Germany built of its most common medium tank. Total American tank production exceeded 88,000 vehicles. German production, including all types, was approximately 67,000. Artillery production demonstrated the disparity even more dramatically. The United States produced over 257,000 artillery pieces during the war. Germany produced approximately 160,000. American factories built roughly 50% more artillery than Germany, while simultaneously producing vastly more trucks, jeeps, aircraft, ships, and ammunition to support these weapons. The numbers became overwhelming when considering vehicles. Germany produced approximately 50,000 Kugelwagens, their equivalent to the American Jeep. America produced over 640,000 Jeeps, 13 times as many. Germany produced approximately 345,000 military trucks during the war. America produced over 3 million, nearly 10 times as many. These disparities extended to every category of military production. American shipyards launched over 5,300 vessels during the war, totaling 53 million tons. German shipyards, despite U-boat construction being a top priority, produced less than 4 million tons. American industrial output exceeded German output by more than 13-to-1 in this critical category. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The ammunition figures were perhaps most revealing. American factories produced 41 billion rounds of small arms ammunition during the war. 41 billion? That was approximately 300,000 rounds for every American service member, or enough to give every person on Earth in 1945 approximately 15 rounds. German production, while substantial, was measured in tens of billions rather than the staggering output America achieved. These numbers represented more than just industrial capacity. They represented a fundamental transformation in how warfare would be conducted. Wars had always been won by combinations of strategy, tactics, courage, and equipment quality. But World War II introduced a new variable that proved decisive: industrial output. The nation that could produce the most weapons, the most vehicles, the most ammunition, and sustain that production despite enemy action, would overwhelm opponents regardless of tactical excellence or strategic brilliance. German soldiers fighting in Normandy after D-Day reported seeing endless columns of American vehicles. German troops trapped in the Falaise pocket watched American artillery expend ammunition at rates that would have exhausted German stockpiles in days. German fighter pilots engaged American bomber formations protected by such vast numbers of escort fighters that aerial combat became suicidal. The psychological impact on German forces was profound. German tankers learned to fear not American tank superiority. The Sherman was arguably inferior to German Panthers and Tigers in direct combat, but American tank numbers. For every German tank destroyed, 2 more Shermans appeared. For every German fighter shot down, 5 more American aircraft took its place. For every German supply depot captured, American forces established 10. Wehrmacht soldiers began finding abandoned American equipment and were shocked by its quantity and quality, rations that were fresh and varied. Medical supplies in abundance, clothing that was well-made and weather-appropriate, equipment that was standardized, maintainable, and available in quantities that suggested inexhaustible supply. German prisoners interrogated after capture consistently reported the same observation. American soldiers seemed to have unlimited resources. Every squad had radios, every company had vehicles. Artillery support was available on demand. Air support appeared overhead whenever requested. Medical evacuation was rapid and efficient. The entire American military machine functioned with a logistical sophistication that German forces could not match. This was the reality that Hauptmann Werner Ossenberg's report attempted to explain to Wehrmacht High Command in December 1944. The Jeep transmission sitting on his workbench was physical evidence of American industrial supremacy. Every gear, every bearing, every precisely machined surface was proof that America could manufacture quality products at speeds Germany could never match. The report from Kummersdorf reached the desk of Reichsminister Albert Speer in late December 1944. Speer, Hitler's Minister of Armaments and War Production, was perhaps the only senior Nazi official who fully grasped the implications of what Ossenberg had documented. He had been trying to explain these realities to Hitler for months. The report gave him new evidence, but he knew it would change nothing. Speer's own journey to understanding American industrial capacity had been painful and gradual. Appointed to his position in February 1942, after the death of his predecessor Fritz Todt in a plane crash, Speer had approached the challenge of German war production with the same methodical efficiency he had brought to architecture. He streamlined production, eliminated bureaucratic obstacles, consolidated factories, and implemented rationalization programs that increased output dramatically. Under Speer's management, German tank production more than doubled between 1942 and 1944. Aircraft production increased substantially. Artillery production expanded. Speer's success earned him praise as the architect of an armaments miracle. Foreign observers credited him with prolonging the war by at least a year through sheer organizational genius. But Speer understood something that many of his colleagues refused to accept. Germany was not producing more because it had become more efficient. Germany was producing more because it had finally committed fully to total war, because it was extracting the last possible output from its industrial base, because it was exploiting millions of slave laborers under brutal conditions, and because it was consuming resources that could never be replaced. German production increased, but so did Allied production, and the ratio between them grew more unfavorable with each passing month. Speer had access to intelligence reports on Allied production. He saw the numbers. He understood their implications. In March 1942, when he took office, German aircraft production was approximately 1,000 planes per month. American production was already exceeding 3,000. By 1944, German production had increased to approximately 3,000 aircraft per month. American production had increased to 8,000. The gap had widened, not narrowed. The same pattern held across every category of military production. German factories worked frantically to increase output while Allied bombing destroyed facilities, disrupted supply chains, and killed workers. German engineers designed ever more sophisticated weapons, while American factories churned out simpler designs in overwhelming quantities. German commanders demanded miracle weapons that would turn the tide, while American generals simply requested more of everything because they knew more would arrive. Speer had tried to explain these realities to Hitler in careful, diplomatic language. He had presented production figures, comparing German output to estimated Allied production. Hitler had dismissed the estimates as enemy propaganda. When Speer persisted, Hitler had accused him of defeatism. The Führer remained convinced that German technical superiority, German fighting spirit, and German willpower would overcome mere industrial capacity. The Ossenberg report provided concrete evidence of what Speer already knew. That Jeep transmission represented American manufacturing philosophy distilled into metal. Design for production, optimize for volume. Standardize components, minimize skilled labor requirements, build things good enough to work, reliable enough to keep working, simple enough to repair, and cheap enough to replace. This philosophy was antithetical to German engineering tradition. German engineers designed the best possible solutions to technical problems. They optimized for performance, not producibility. They created machines that were sophisticated, complex, and required skilled operators and maintainers. The German way produced weapons that were often superior in direct comparison to Allied equivalents. The King Tiger tank could destroy 5 Shermans in direct combat. The Messerschmitt Me 262 jet fighter could outfly any Allied propeller-driven aircraft. German U-boats were more sophisticated than Allied submarines, but superiority in individual combat meant nothing when the enemy could field 10 tanks for every one you produced, 20 aircraft for every one you built, 5 ships for every one you launched. The mathematics of attrition warfare were brutally simple. If the enemy could replace his losses faster than you could inflict them, you would lose. If the enemy could reinforce his units faster than you could destroy them, you would lose. If the enemy could sustain his offensive longer than you could maintain your defense, you would lose. German military leadership had understood these principles when planning Operation Barbarossa, the invasion of the Soviet Union. The plan had called for a rapid campaign of 6 to 8 weeks, destroying Soviet forces before they could mobilize their vast industrial capacity. The plan had failed. The campaign had stretched into months, then years. Soviet factories, evacuated beyond the Ural Mountains, had begun producing weapons in quantities that German intelligence had not believed possible. Now, in the West, Germany faced the same problem magnified. American industrial capacity exceeded even Soviet production. American logistics were more sophisticated. American military organization was more efficient. And unlike the Soviet Union, which had absorbed devastating losses in 1941 and 42, American industry operated beyond the reach of German bombers, safe behind 2 vast oceans, growing stronger with each passing month. Speer understood that by December 1944, Germany had already lost the war. The only question was how long the dying would continue. Hitler's decision to launch the Ardennes offensive, the Battle of the Bulge, represented a desperate gamble to split the Allied forces, capture the port of Antwerp, and force a negotiated settlement in the West. Speer knew the offensive would fail because he understood the logistics. Germany lacked the fuel reserves to sustain a major offensive. Even if initial attacks succeeded, American forces would simply fall back, regroup, and counterattack with reinforcements that Germany could not match. The offensive began on December 16, 1944. Initial German attacks achieved surprise and made significant gains. American forces were pushed back. For a few days, it seemed the German gamble might succeed. Then, American reinforcements arrived. Troops, tanks, artillery, ammunition, fuel, medical supplies, everything an army needed to fight, all flowing through supply lines that stretched back to ports receiving endless shipments from American factories. Within a week, the German offensive had stalled. Within 2 weeks, it was being pushed back. Within a month, German forces had been driven back to their starting positions, having lost irreplaceable men, tanks, artillery, and fuel in an offensive that gained nothing. American losses were quickly replaced. New divisions arrived from the United States. Replacement tanks rolled off transporters. Ammunition depots were restocked. The American military machine absorbed the blow, staggered briefly, then continued its relentless advance. German soldiers fighting in the Ardennes reported the same observations their comrades had reported in Normandy. American artillery support was overwhelming. American air power dominated the skies whenever weather permitted. American logistics seemed limitless. Captured American positions contained supplies that German troops had not seen in months: fresh rations, warm clothing, medical supplies, ammunition stacked in quantities that suggested it was disposable. One German soldier, captured during the retreat from the Bulge, told his interrogators about finding an abandoned American supply depot. He described seeing hundreds of jeeps, dozens of trucks, fuel drums stacked in long rows, ammunition boxes piled 8 feet high, ration crates extending further than he could see. He had asked his American captors how this was possible. How could one nation produce so much? The American soldier had laughed and said simply, "We've got a lot of factories." That answer, simple and devastating, captured the essential truth. America had a lot of factories. Factories that were not being bombed. Factories staffed by workers who were well-fed, well-paid, and motivated. Factories supplied by railroads that functioned efficiently. Factories powered by electrical grids that operated reliably. Factories using raw materials extracted from mines that were productive and safe. Factories producing goods that were shipped on trucks that ran on fuel that was abundant and cheap. Germany had none of these advantages by late 1944. Allied bombing had disrupted German production repeatedly. The loss of Romania's oil fields in August had created fuel shortages that crippled military operations. The transportation system was collapsing under constant air attack. Workers were malnourished, exhausted, or had been drafted into military service. Raw materials were scarce. Every aspect of German war production was deteriorating, while Allied production continued to expand. Speer's files contained a comparison that he found particularly sobering. In 1944, American factories produced 96,000 aircraft. Germany produced 39,000. American production exceeded German production by a factor of 2.5. But the comparison became more devastating when examining heavy bombers. America produced over 23,000 B-24 Liberators and B-17 Flying Fortresses in 1944. Germany produced approximately 700 He-177 and Ju-88 heavy bombers. American heavy bomber production exceeded German production by a factor of 33 to 1. 33 to 1. No amount of pilot skill, tactical brilliance, or technological innovation could overcome that disparity. German fighter pilots shot down American bombers in substantial numbers throughout 1944. It made no difference. For every bomber destroyed, 3 more appeared. The American bomber offensive continued despite losses that would have ended any German offensive. The same arithmetic applied to every aspect of the war. American submarine production exceeded German U-boat production. American destroyer production was measured in hundreds, while German production was measured in dozens. American aircraft carrier construction gave them total naval air superiority in the Pacific, while Germany could not even maintain its surface fleet. In every category, American production overwhelmed German capacity. Speer drafted a memorandum in January 1945, attempting one final time to explain these realities to Hitler. He wrote carefully, avoiding language that could be construed as defeatist. He presented production figures. He noted the impossibility of increasing German output further. He suggested that diplomatic negotiations might preserve something from the wreckage. Hitler refused to read the memorandum. He ordered Speer to focus on increasing production, not making excuses. By March 1945, the situation had become hopeless. Allied forces crossed the Rhine River. Soviet armies approached Berlin from the east. German industrial capacity had collapsed. Factories lacked power, materials, and workers. Transportation systems had ceased functioning in many areas. Military units reported ammunition shortages, fuel exhaustion, and the inability to move even when orders were given. Speer made a final decision that would later contribute to his survival at the Nuremberg trials. Hitler issued orders for a scorched earth policy, demanding that all infrastructure, factories, bridges, and resources be destroyed to prevent their capture by Allied forces. Speer quietly countermanded these orders. He understood that Germany would need these resources to survive after the war. He began working to preserve what he could, knowing that Germany's future depended on retaining some industrial capacity for post-war reconstruction. The war ended in May 1945. Germany surrendered unconditionally. The final statistics told the story of industrial warfare with brutal clarity. America had produced over 297,000 aircraft during the war. Germany produced approximately 119,000. America built 88,000 tanks. Germany built 67,000. America constructed over 3 million trucks. Germany built 345,000. American factories had simply outproduced German industry by factors ranging from 3-1 to nearly 10-1, depending on the category. After Germany's surrender, American officials raced to find Speer. They wanted to understand how German production had functioned despite years of strategic bombing. Speer cooperated fully, sharing detailed information about German manufacturing techniques, organization, and decision-making processes. He hoped this cooperation might lead to more lenient treatment at his eventual trial. During these interrogations, American officials showed Speer production statistics from American industries. Speer studied the numbers carefully. He was asked if he had known during the war that American production exceeded German capacity by such margins. Speer confirmed that he had known. He explained that he had tried repeatedly to make Hitler understand these realities, but the Führer had refused to accept that industrial capacity would determine the war's outcome. One American interrogator asked Speer the obvious question: "If you knew Germany could not match American production, why did you continue fighting?" Speer's answer was complex. He cited loyalty to Germany, hope that new weapons might change the balance, belief that political divisions among the Allies might lead to a negotiated settlement. But underlying all these rationalizations was a simpler truth. Speer had understood Germany would lose, but had lacked the courage to act on that understanding until the final months of the war. The Jeep transmission that Hauptmann Werner Ossenberg had examined at Kummersdorf in Therese, December 1944, had survived the war. It remained in storage at the facility when Soviet forces captured the area in April 1945. Soviet technical intelligence teams examined the facility thoroughly, cataloguing German research and confiscating anything of value. They found the Jeep, still partially disassembled, along with Ossenberg's detailed technical report. Soviet engineers read the report with interest. They understood immediately what Ossenberg had documented. The Americans had achieved something that Soviet industry was still struggling to replicate: true mass production of complex mechanical systems with consistent quality. The Soviets had managed to produce vast quantities of tanks, aircraft, and artillery during the war, but their production had relied heavily on simplification, accepting lower quality to achieve higher volume. American industry had managed both quality and quantity simultaneously. The Jeep itself became part of the Soviet technical intelligence collection. It was eventually shipped to the automotive research facility outside Moscow, where it joined other captured vehicles. Soviet engineers studied it extensively, using its design principles to influence post-war Soviet military vehicle development. The transmission was carefully measured, its components analyzed, its manufacturing techniques documented. But the real legacy of that Jeep transmission was not technical, it was philosophical. The examination of that single component had crystallized for Hauptmann Werner Ossenberg, for Reichsminister Albert Speer, and eventually for the Soviet engineers who studied it after the war, a fundamental truth about modern warfare. Industrial capacity had become the decisive factor in total war. The courage of individual soldiers still mattered. Tactical skill still influenced battles. Strategic planning still shaped campaigns. But underneath all these traditional elements of warfare lay a new reality. The nation that could produce more weapons, more vehicles, more ammunition, and sustain that production despite enemy action, would overwhelm opponents through sheer material superiority. This principle, demonstrated so convincingly by American industry during World War II, would shape military planning for decades after the war ended. The Cold War became, in many ways, a competition of industrial capacity between the United States and the Soviet Union. Both nations built massive military-industrial complexes, each attempting to match or exceed the other's production. The nuclear arms race was fundamentally a manufacturing competition, each side producing thousands of weapons because quantity provided deterrence. The lessons learned from examining that Jeep transmission influenced American military procurement for generations. The Pentagon emphasized reliability and maintainability in weapon systems. Military specifications required that equipment be serviceable by personnel with minimal training. Logistics became recognized as equally important as combat capability. The entire philosophy of American military power rested on the ability to produce, transport, and maintain equipment in vast quantities over global distances. General George C. Marshall, Chief of Staff of the United States Army during the war, called the Jeep America's greatest contribution to modern warfare. He understood that the vehicle itself was not the contribution. The contribution was the industrial system that could produce 640,000 of them, while simultaneously producing millions of other items. The Jeep was simply the most visible symbol of American manufacturing supremacy. General Dwight D. Eisenhower, Supreme Commander of Allied forces in Europe, later wrote that he considered the Jeep one of the 4 tools that won the war, alongside the Douglas C-47 transport aircraft, the landing craft, and the bulldozer. Notably, none of these were weapons in the traditional sense. They were tools that enabled logistics, that allowed American forces to move, to build, to supply, to sustain operations across vast distances. They were the unglamorous machinery of industrial warfare. British Prime Minister Winston Churchill, observing American production firsthand during his wartime visits to the United States, remarked to advisers that America's industrial capacity was the factory that changes everything. He understood that Britain's survival had depended on American production as much as British courage. The weapons, vehicles, food, and materials flowing across the Atlantic under Lend-Lease had sustained Britain through its darkest hours. Without American industry, Britain might have been forced to negotiate with Hitler. Soviet Premier Joseph Stalin, despite his complicated relationship with the Western Allies, acknowledged American industrial assistance. Soviet factories had produced remarkable quantities of weapons, but they had done so using American trucks for transportation, American locomotives for railways, American aluminum for aircraft, American petroleum products for fuel. Stalin once toasted American production at a wartime conference, saying American factories had provided the logistical foundation that allowed Soviet forces to advance. The final irony was that Germany had possessed the technical knowledge to understand these realities before the war began. German military analysts had studied American industrial capacity during the 1930s. They had calculated that American factories, once mobilized for war production, would overwhelm German output. These analyses had been dismissed by Hitler and other Nazi leadership as defeatist or as Allied propaganda. The decision to invade the Soviet Union in June 1941 had been partially motivated by the need to secure resources before American entry into the war made Germany's position hopeless. Hitler understood that time favored the Allies because American industry would eventually tilt the balance. His strategy required defeating the Soviet Union quickly, securing access to oil, grain, and industrial resources, and forcing Britain to negotiate before America could fully mobilize. The strategy failed at every level. The Soviet Union did not collapse quickly. Resources could not be extracted and exploited fast enough. Britain did not negotiate. America entered the war and began mobilizing its industry on a scale that exceeded even pessimistic German estimates. By 1943, the arithmetic of industrial warfare had doomed Germany. Everything that followed was simply the working out of mathematical certainties. That Jeep transmission, sitting on Werner Ossenberg's workbench in December 1944, had been physical proof of these mathematical certainties. Every precisely machined gear tooth, every carefully ground bearing surface, every standardized component had been evidence that Germany was fighting an opponent that could simply outproduce them to death. Ossenberg survived the war. He was captured by American forces and briefly interrogated about his work at Kummersdorf. He provided technical information about German research programs, vehicle development, and manufacturing processes. He was released in 1946 and returned to civilian life, eventually working for Opel again in their engineering department. He never spoke publicly about his examination of that American Jeep transmission, but colleagues later reported that he considered it the moment when he understood Germany would lose the war. Speer stood trial at Nuremberg for war crimes. He was convicted and sentenced to 20 years imprisonment for his use of slave labor in armaments production. He served his full sentence, being released in 1966. He spent his remaining years writing memoirs and giving interviews, attempting to craft a narrative of himself as the good Nazi who had tried to moderate Hitler's excesses. Most historians now reject this self-portrayal, recognizing that Speer was fully complicit in Nazi crimes and his claimed ignorance of the Holocaust was a carefully constructed lie. But whatever his moral failings, Speer's understanding of industrial warfare was accurate. He had recognized that Germany could not match Allied production and that this disparity would determine the war's outcome. His tragedy was not lack of understanding but lack of moral courage to act on that understanding until far too late to matter. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.